Good afternoon, I'm Bob Aarons, host of the seminars. Thank you very much for showing up, especially thank you all for bringing so many kids. This is really great. It's my enviable job of introducing Ed Friedman here, and I could do this for an hour, so I won't. I can tell you that Ed's been with us for a long time, and then he left, and then he's been back for a long time. Back in the day when the internet was starting to kind of crank up, Steve Kilson was asked by Ed Vandenor, who was running the place in those days, to kind of figure out how to get us into the ball brain, internet sort of community. And Steve did all that. That's kind of where your ball front page comes today. There's Heritage back there. Somewhere in there, the only person in the company who knew what the letters URL stood for was him. And I still don't know. Universal Resource Language?
Somebody else.
Locator. Okay. And he taught internet classes here when it was really obscure and tough. And so he's been at the cutting edge of everything. I should tell you that one time he and I worked in Tech 3, and he got tired and he said he was going to quit because it wasn't exciting enough. And so as a friendly gesture, I offered to bring in a large caliber handgun, and every once in a while just push my chair back from my desk, fire around down the hall just to put some excitement into Ed's life. But it turns out he grew up in Detroit, and that wasn't going to get the job done. So he left and went away and came back. And now he just does fantastic things, and everywhere I turn around, there's Ed doing something wonderful, including this stuff. So enough of this. He likes questions. He's going to show you lots of stuff. You can always ask him, say, hey, what happens if? So be interactive, and you'll see that he's a real fireball. So if you're ready, I'm ready.
Okay, I'm ready. So I'm Ed Friedman, and Bob's right. I started at Ball in '93, and except for a little 5-year interlude when I was in prison at Boeing, I've been here ever since. So what I want to talk to you today about is animation physics and using new free tools that go very well with modern computing technology. I'm going to use this laptop, which I inherited back in 2006, so this is probably a 5-year-old laptop. If you have a more modern computer that has dual core, fancy Dan supercharger stuff, the animations will look more physically real because the processor will be able to do all the right things. So a couple other comments. I have a document here that is my script, and it has a whole lot of embedded links to various things I'm going to show you. And if you want a copy of that, just write to me and I'll send you the...
Did it boot? I don't think you double clicked it.
I didn't, but I...
Never.
Okay. So, okay. The other thing is, I'm going to show you a lot of different things from a number of different...
This is the beginning of the animation. Ed gets really animated at this point and starts talking about Bill Gates.
No, we're good. It's all good. So what I was going to say is I'm going to show you a number of different animation tools. They're all free. So for you kids, if you have access to the internet, great. If mom and dad control your access, have them put this stuff on your computer, and I think you can have a great time with it. And my last comment before we get started is I'm bound to make some mistakes as we do this because I'm doing it in real time. And I'm going to sit down so I can do mouse manipulation and so forth. So bear with me if I start something, I promise it's going to happen, and then it doesn't happen. I may have to do it a couple of times to get it to work. So let's start with a kind of interesting piece of software called Alice. How many kids know about Alice? Anybody? Alice? No? Okay, good. So you're going to learn something new.
I remember a Wonderland.
Oh, well, it's associated with that. You'll see up on the screen a mention of Randy Pausch. Some of you have read his book called The Last Lecture, which is his adventure with cancer, and he eventually died from his disease. He was a faculty member at Carnegie Mellon University, a premier university for computer science, and he ran a group that was concerned with the success rate of new, very smart young people coming into the university wanting to be computer scientists, and they took one computer class and dropped out. Because what they encountered was all the little trivia you have to deal with, when you're programming in C++ and so forth. If there's a semicolon in the wrong place, your code doesn't work, and it could take you 3 hours to figure it. And people got frustrated and quit. and the faculty at the university was frustrated with this, and they didn't want that to happen. So they decided we've got to invent a way for young people entering the computer science world to get past this problem with little details derailing their efforts. And they invented something called Alice. So let me show you Alice. It's a programming tool. It comes in two forms. And the reason it does is there's a version that cancel that. There's two versions. One designed for the university students, and another called Storytelling Alice, which is designed for middle school students. And as you can see, I'm going to show you Storytelling Alice. And what you do with this is, it takes like any other software. It takes a little bit to get going. And in a second now it'll come up. And here's the way this works. We don't need the tutorial. You get this interface and you say, I would like to add objects to this space. And you can manipulate the space, you can move things around. And if you want to add, let's add something. Where's my, this is not what I want. See, this is what I was talking about. Oh, let's go to the local gallery. This is built into the software. There's, in the college version, you can also link to the internet and see a huge array of these characters, not just characters, but scenes, all kinds of stuff. So let's go here to adults, and we're going to add Joe Meany, there he is, to this world, and we'll add Mrs. Miller. And you see, I'm not typing at all, I'm just putting things here on this grassy field. And you have many, many kinds of backgrounds you can use with Alice. And we'll say done. And what we're going to do now is create what's called a method. And it doesn't matter what we call it. And we can ask the software to do things with Joe Meany. So for example, well, first of all, I clicked on this. You can see you have these controls. Anything you do in Alice, you can associate with a keystroke, a mouse click, interaction between the characters, so you can use this as a game building situation. And what I want this to get bigger. So we've added our objects. I'm not happy. Oh, you know what it might be? Interaction between the screen and the computer. But anyway, here's what we can do. We can say that we want Joe to do something. We can drag it over here, and we can say, Joe, walk 1 meter. And we can say, and because we have this other character, Mrs. Miller, we can drag her over here, and we can say have her turn left a half a resolution. And when you play this, we'll redo it. So you can control how these characters interact. And like I said, you can use mouse clicks, particular keyboard strokes, or interactions of these characters. And you can build games or animations or tell a story using this. And if you have a really complicated thing, you can use this slider. You can speed it up. So if it's let's say hundreds and hundreds of things happening, and it takes minutes for it to play, and you're checking what you've done, you can speed it up using this. And you can take a picture here if you compose something that you want to do, that you want to share with somebody. You can take a picture of it. So you have these kinds of controls, and in the more advanced version, the university version, as I say, you have thousands of these little avatars. Now, let me point out something else to you. Let's stop this. Mrs. Miller is made up of arms and legs and a head and so forth. So if you keep clicking here, you get down to the point where you can manipulate Mrs. Miller's left hand, or Joe Nini's right foot. See, we've got control of his hips. Here's his right leg, his lower right leg, his right foot. And if you watch the Alice tutorials, they have an ice skater skating around an ice rink, jumping over things, avoiding obstacles. And so the kids in the room will, once they see how to do this, they can be very creative and generate all kinds of games and animations using Alice. And so for moms and dads, I recommend you look for Storytelling Alice if your kids are under, say, 15 or 16. The university version's available. You get it from Carnegie Mellon. And I should have mentioned that there's you can easily find this. And you'll find it amusing. Okay, any questions about Alice? All right?
Yeah, okay.
What about if you're downloading these things? What's the safety protocols?
Well, I'm concerned about that, and Carnegie Mellon University issues Alice. I have not had no problems with that. Next, I'm going to show you SketchUp, which is a Google product, and actually invented here in Boulder. I'll tell you a little bit about that in a second. I had no problems with that. And I've had no problems with anything I've been using that I'm going to show you today.
Will this also work in the Mac world?
Yes. So, oh yeah, good. I'm glad you asked that question. Most of what I'm showing you today will work on Mac. A few of the things will work on Linux if you happen to be a Linux user. So I'm not concerned about safety on these things. Gary?
What sort of games can you create?
Well, the best way to look at this, Gary, gets me into something I should have mentioned earlier. On all this software, as I say, I'm going to show you a number of different software packages. The best place to get really nicely done finished products and training is on YouTube. There's just thousands and thousands of video products out there explaining what you can do and people bragging about what they've achieved. And a huge fraction of what you find on YouTube on all these things is done by kids. And when we get to Blender in about a half hour, keep that in mind, because Blender is very sophisticated, very capable animation tool. And as I say, a huge fraction of the training videos are done by kids. Most of my training on Blender comes from a series of training videos done by somebody who was 11 when he started creating training videos. He's now a university student, and you can see him, you can hear his voice changing as the videos go along. But he's produced 30 or 40 training videos over the last 8 years. So what can you do? It's the infinite number of things, and Alice has a lot of adherence. So let's move on to,
Yeah.
Yes?
Could you try and summarize what are the differences between Storytelling Alice and University Student Alice?
Yes. Okay, University Alice has a much wider array of motions and controls associated with a character. So if you pick like the ice skater and expand all the things that ice skater can do, there's a tremendous amount of control that you have over the angles between the foot and the leg, and forces that can be applied. It's much more comprehensive in that way. And the thing about Alice that you should keep in mind is Carnegie Mellon designed this specifically to teach object-oriented programming without having to worry about typing exactly the right characters in the right way. So that's their intention. And by the way, their retention rate of students in their freshman computer science curriculum has gone way up, because this is what they encounter, is something where you don't do any typing. You just think about designing the motions of the characters and having them do what you want to do. So now let's move to Google SketchUp. Any SketchUp users here? 1, 2, okay. So here, let me quickly tell you how I found SketchUp. It has to do with Hurricane Katrina. During the Katrina disaster, CBS and other news outlets were using Google Earth to show the flooding in New Orleans, and I noticed there were 3D buildings standing on top of the map of Earth, because I knew what to expect, since all of you do too. Remote sensing images obtained from Digital Globe and companies like that, except I noticed they're 3D images. So a little research revealed that all those images were created using Google SketchUp. And most of you I know are familiar with Google Earth. Next time you get a chance, if you haven't turned on the 3D building feature, fly to Paris, France, and look at the Eiffel Tower. It's a very sophisticated and very accurate 3D representation of the Eiffel Tower, where you can see through the girders and see down to the ground, which is of course a two-dimensional image obtained from a spacecraft. All that imagery was generated using Google SketchUp. And in fact, now SketchUp has millions of users. In fact, was invented here in Boulder, not right, kind of across the street from Mike's Camera. Some of you know where that is. And it was about 10 years in the development, and then Google bought this outfit that produced SketchUp. And today I'm going to show you a quick survey of how to use SketchUp, and then the overlay called Sketchy Physics, because today's about animation. So let's start SketchUp, and I'll show you how it works. And once again, this is free. You get it from, easy to find it on just doing a Google search for Google SketchUp. And so this is what it looks like. Now, there's some menus here that are part of Sketchy Physics, and we'll get to those. So just to keep things clean, let's get rid of our friend there. And let me show you how this works, and then you, particularly you kids, you'll immediately be able to see how to use this to draw 3D representations of things you're interested in drawing. So let's start by, let me just draw a rectangle. Now I want you to see something here. SketchUp has what's called an inference engine. So when I started this, I typed the letter R. I'm not going to explain every keystroke I'm doing, I'm just going to show you the result. But I was near the origin, and it produced this yellow ball because it knows I want the first thing I draw to be near the origin. So we got a square, and it tells you, as you're drawing rectangles, for example, it has little indicators that you are going to draw a square, a perfect rectangle, various other kinds of common things. And then I'm going to push this, and we can look around. And the fun part of this is now I can draw a rectangle on this face, and I can select this, and I can delete. Where's the delete key on this computer? Okay, and you can immediately see that we're looking inside this box. So there's nothing more to it than that. Now let's draw a line on the roof. Now you see, once again, the inference engine, see the blue dot? I got near the center of this line, and it said, oh, he wants to be at the center of the line. So the inference engine did that for me. And now we're going to move this, and we have something like a little doghouse or whatever. Now the interesting thing is, if I grab this, you can see that this building is plastic. It's the whole thing reacts if I move that line. And so if you want to avoid that, you can create something called a group, just like in PowerPoint. The difference is here, we're able to draw just about anything we want to do. And now, just give me a second here. I want to look at my script and make sure inference engine. Oh, okay. So now what we're going to do is talk about viewing shadows. And I don't have room on the toolbar right here, but when you're viewing shadows, you can pick the time of year and the time of day, and the shadows move around. I don't know if I have the calendar set up. I don't, so we won't get stuck on that, but anybody using this will quickly discover how to use the calendar to, so if, for example, if you're going to make an addition to your house, you can draw a model of your house and then draw a representation of the addition you have in mind, and then watch how the shadows fall on that addition at different times of the year, or you can put trees and so forth, and you can make decisions essentially do everything before you talk to your architect and make sure you're going to be happy with the shading that occurs in the winter and that sort of thing. All right, so now let's do something a little more sophisticated. So I'm going to select this and delete it. Now, what I want to show you is a lathe thing. Let's say we draw a shape like this. Okay, now what I've drawn is a kind of an odd-looking plane, and I'm now going to draw a circle at the origin. Now, here's where the inference engine comes in. If you're kind of looking down and you choose the circle tool, it wants to be laying on the plane that you're looking at. If you're looking here and you put the circle there, it knows to put it perpendicular to the plane. I think we're going to turn off the shadows because it's a little distracting. Now, let's undo that. Now let's select this odd shape, and we're going to use something called the Follow Me tool. Where did he go? Oh gosh, toolbars. Hang on, I failed to do, this is what I was talking about earlier. So now I'm wasting your time. Modifications. Oh, okay. So this right here, that's the Follow Me tool. So we pick this shape we're interested in. We say Follow Me, and what it did is it drew this circle around the perimeter of that shape I drew. Another way to do Follow Me is we pick the circle first and say Follow Me, and then we get a three-dimensional a lathe of this weird object, and because we have the control, we can look inside. I don't know if you can tell, but we're looking inside. All right. Now we also have a paint bucket. Where did he go? Sorry, toolbars. I got to find the paint bucket, so bear with me. While I'm here, you have face style. See, so you can do transparencies, or you can see through, and you have different kinds of controls you can use. I do want to show you something with the paintbrush, though. Color. What happened? All right. Here's the paint bucket, and by the way, we're a little crowded here because the screen of the projector is not as big as you'd normally use. So we have lots of colors here, but we have other stuff, including translucence. So if I paint this translucent, you can see that it's sort of like blue glass. We can see through and see the different elements of this thing. So I think you get the idea, or you can do glass blocks. We also have so let me move this kind of out of the way, and let's start another drawing, because we're going to get to sketchy physics here in a second, but I'm almost done with this. So if you draw a rectangle and you want to actually have fencing there, you can do this. You can do fencing, and maybe you like that kind of fencing. Ooh, what happened? Oh, we got to zoom in. And what it's done is made like a wire screen that we can see through. Okay, so this is all good, but this is not why we're here today. We're here today to talk about animation. And this, I think you'll find this amusing. Let's just get rid of all this. Okay, so I think what I'm going to do, well, unfortunately, I've got multiple toolbars here, but we will soldier on. All right, let's talk about these commands here. These are associated with sketchy physics, and I'm going to show you a simple thing, and then I'm going to show you a couple of things I've prepared. Actually, you know what I want to do is I want to get rid of some of these toolbars because they're going to prevent us from really enjoying what we're going to see. We're almost there. Come on. stinker. Okay. So the way this works is we have these animation tools. I just clicked on this button here, it generates a plane. And by the way, now, this is in a gravity field. So if I didn't do this first, and then I chose this cube, which I will, there's the cube. If I hadn't put this plane here and I ran the game using this button, the cube would just fall to infinity. So what we're going to do now is lift this cube up. Let's center this a little bit, like that. And now I'm going to start the game engine. And this cube, I can do stuff with it. Whoops. It's gone. So let's.
Reminds me of that black hole animator we saw about 2 months ago.
So what we've done is put this cube above a plane that's not going to move, but the cube is. And let's zoom in a little bit. I want to show you a couple of features here. The cube, can you see it bounced? And it does have sort of an elastic behavior that in sketchy physics you can't control. When we get to Blender, then you'll see what you can do with a really sophisticated animation engine. So at this point, let's go to a set of things I prepared. I'm kind of like Julia Child. Remember her?
Yeah.
She had that chicken already done that she could show you. So let's.
You got to do the voice though.
I'm not going to do the voice. So let's view these as thumbnails, and it'll make it easier for me to show. Oh, okay. Here. Let's just open this, and you can see what we have here. We have a cone standing on its point, and a ball, a big ball and a little ball that are ready to go, and we start the animation, and things interact. I wish this wasn't getting in the way, but there's not much I can do about it. Well, if I get rid of it, it wants to appear every time I run the animation. So once again, things standing on their point fall over, and notice this cone interacted with the ball, hit the ball, and the ball rolls, and the other ball rolled down the plane and got trapped in this little cup that I prepared. Let's try another one that's a little more complicated.
So have you ever spent time making a Rube Goldberg machine on this?
Oh yeah, and I'm going to show you Rube Goldberg here in a second. Let's do this one.
You don't know Ed yet, do you?
Go away. This one I didn't do. See, so these things interact. I don't know if you can see, this is kind of the shape of a lozenge or a flat pill, and these things have energy, they have some damping, and they'll roll around, and you can move them. I'm just grabbing these with the mouse and throwing them around. So let's respond to the question of let's see if it's here, thumbnails. Oh yeah. So this, stop. You can see what we have here. Now, I should just tell you that Sketchy Physics has in this panel right here, motors, gyroscopes, springs, pistons, all kinds of controls you can use to manipulate what's going to happen. So what we have here is something like a piston engine, a globe going around, and all these things happening at once, and you can kind of grab things and throw them around. I mean, it's just... I want to find one more of these that I created. Let's see, where is it? Let's get examples. Let's do this one. I don't know why this won't continue to show me this view. I have a a building I built that collapses. I can't find it right now. I'm frustrated.
Go back one level, I think you saw it.
Down.
No, where you, go back to where you just were, go back one, there's a thing called quake.
That's not mine, but that's all right.
Well, the building collapsed.
Yeah, let's try this building collapse. Okay, so the way this one works, we've got to start the engine here. Now nothing really happens right away until you